Okay, guys. Has it been calibrated?
Yes.
Yeah?
Yes.
Fantastic. Oh. All right, guys.
Si on peut ramener un peu le portique par là. On peut avancer un peu le...
On this torpedo, it's about 70 pounds worth of frozen CO2, which is equivalent to the emissions of an SUV driving about 70 miles.
It's time for the big drop. Suddenly, the sea begins to roll. To stop the torpedo from swinging, Nick lowers it into the water. As it steadies, a launch window finally opens.
Everyone ready? Ready, guys? Ready? 3, 2, 1, release! Woo! That went seriously quickly. You see that go down? Amazing.
A sonar locator on the torpedo sends a signal back to the ship.
C'est bon?
Yeah, it's okay.
Oui.
The computer needs a little time to organize the results. In the meantime, Basil is optimistic.
So far, it looks like it works amazingly well. Yeah. Until we get the data back, we can't fully comprehend exactly when on. Fingers crossed, we got some penetration into the sediment at the bottom. But as I said, yeah, we don't know yet.
Minutes later, Nick gets the results. The torpedo hit a top speed of 80 kilometers per hour. For every 10 meters it dropped, the water pressure increased by 1 atmosphere. At 50 meters and 5 atmospheres, the carbon dioxide stopped bubbling off. When the torpedo buried itself, the CO2 was locked below the sea floor.
Well done, guys. Congratulations.
I've never seen an experiment carried out like this so successfully in one shot. It's just amazing.
The trajectories through the water, straight down, which is fantastic. It couldn't have gone better.
This was just a small-scale test to prove the concept. A global-scale solution would mean sending billions of tons of CO2 to the bottom in huge torpedoes.
This would be 500-ton penetrators, so we're talking about things that are 30 times the size that we did today. And you would probably be launching them at something like 1 an hour.
These 500-ton torpedoes would stand 30 meters high and measure 4 meters in diameter.
There are so many huge areas within the ocean that the capacity to store CO2 is probably infinite.
Storing carbon dioxide beneath the ocean floor looks promising. But if Jen and her group can't come up with an efficient design for the scrubber, they won't have anything to store at the bottom of the ocean.
Principalmente em um coeficiente intelectual alto ou muito alto, é heterossexual. O seu aspecto físico é normal e até atraente. Tem amigos e amantes, tem até esposa e filhos. É o que muitas pessoas chamariam um tipo fixe. Este homem é um assassino em série. Assassinos em Série. Estreia domingo, 23 de agosto às 22h10. Só no Discovery.
The Discovery team has shown that it's possible to store carbon dioxide by burying it beneath the ocean floor. But eco-engineer Jennifer Languel has run into roadblocks while trying to build David Keith's scrubber machine. So far, the carbon footprint of the first prototype scrubber is far too big.
We did a test, and the test gave us really bad efficiency numbers.
After discussions with David Keith, Jennifer heads to Indiana, hoping to fix the problem. Jen found that the air fan on the prototype scrubber used too much electricity compared to the amount of carbon dioxide it extracted from the air.
The goal here is to try and design and build a fan that's going to give us the efficiency we need.
Her strategy is to modify a time-tested design to push air through the scrubber. It's the common desktop fan. It can move high volumes of air. The only downside is that the blades throw lots of air to the side. Customizing the blades should solve the problem. But the fan must be at least 15% more efficient than the prototype.
So what I have here is the actual center part of the van axle fan. And what we've done is we've actually welded on blades at a specific angle. And that specific angle helps us reduce the pressure in the fan, which increases the energy efficiency.
The optimized propeller fans will be installed in a tube. That'll prevent the air from being forced to the sides. But this modification also creates turbulence that could hurt efficiency. So a set of fixed blades is installed behind the fan to smooth out the rough air.
We don't even know how this is going to perform, but we want to try something.
Correct.
To see if we can actually get the efficiency down. Can we go ahead and get this thing started? It's looking good. Can you pull up the comparison? What I'm seeing is that we have anywhere from about 18% to 29% more efficiency with this van axle fan.
Correct.
Perfect. It is much more efficient than the original fan. Now I need to get it back to the scrubber to see if the entire scrubber system will work more efficiently.
While Jen readies the fan for shipment, Dr. Frank Zeman is building a new prototype carbon scrubbing machine.
I'm feeling very excited about this. We're going to put it together. It's going to look very different from everything we've done so far. It's going to be big, and it's going to be a real device, industrial application.
The scrubber's made from sheets of PVC plastic, bolted and welded together. This new design is based on equipment used in chemical plants to clean sulfur from the air.
This is the C section, this is the B section.
Frank modifies the machine with the special perforated packing to optimize the distribution of the caustic soda used inside. As it passes through the metal packing, the caustic soda spreads out over the sheets of corrugated stainless steel. This exposes more of it to the air, allowing it to absorb more CO2. The packing fits together to create a multi-layered sleeve that lets the air flow through easily. This should allow the scrubber to use less power. But David Keith wants absolute proof.
To be honestly true, I didn't really believe the spec sheet data from the packing company, and we wanted to really try it for ourselves in a way that would give us some confidence.
That is tight. If this doesn't work, and the numbers don't turn out, I'll be disappointed.
Let's get some bolts up here.
Jen's new fan arrives.
Wow.
Yes, a little bit bigger.
Changed a little bit from the last one.
Now it's time to ship the scrubber to the test site in Canada to run it for real. Basil